Mariya, 1 second. I will introduce you and then start. The recording has started, but let me start by saying that today is March 16, 2022, and we are in the second track of our Disasters and Pandemic Symposium, the summit this year. This track is particularly concerned with pandemic, and in this track today our speaker is Mariya Evtimova-Gardair. She has already given us a brief introduction, but I will request her to repeat that again. I'm Ravi Sharma, and we have been joined by the track champion, Dr. Ram Sriram, and other colleagues. The biggest thing I want to highlight is that with lot of hard work, Mariya has been progressing and publishing at this stage, already published 2-3 ISBN publications, and more are in the coming. And the rest, Mariya will tell in her own language. Welcome, Mariya.
Thank you very much, Ravi. The topic, it is related with COVID, with the searching information of COVID-19. And the title is Semantic Agents System for Personalized Searching. So the title and the topic I'm going to describe is for the searching system. I'll talk about the agents a little bit and their connection with the semantic, so that to give a reasonable searching in internet for COVID information. And now I will introduce myself and my experience. During the last 2-3 years, I have been working in France. And before that, I was working in Bulgaria in Technical University Sofia. Then I moved to France and I have experience in different research projects and also in the teaching. So I will introduce my research projects. One of the latest research projects is related with teaching. It's ERUA, and the name of the project is ERUA. It is in Paris, in the University Paris 8. And inside of this project, we were having Night of Ideas last week, and my idea was selected. It is for student e-guide, creation of student e-guide. So we are planning to create a project about that. And then I have submitted an application for COST project, European project. Most of the projects I have been working for are either national or either European projects. One of the projects is for action research of mental health. For distributed knowledge graphs, and one of it is submitted for sugar intake from beverages. It's European projects. Projects that I have been working for are from data to knowledge to agronomy and biodiversity. That's a project also with with the cooperation of Stanford University. It's a national project, but just as advisor of the project, it was related with participation of the Stanford University. Then a national, that's an infrastructure for forest resources in silver infrastructure in France. National project, multi-agent system for searching of medical information in internet. And one European project, large-scale industrial structural optimization for advanced applications. That's a project related with meshing and 3D dimensional images that are particularly described and used in CAD products. For example, company like SolidWorks create CAD product, CAD software for machine industry, but it's outside of the topic now. And the other project is in the domain of, it is related with the semantic, but it is in the domain of social sciences. Then I have several projects. I can describe several articles that are related with the healthcare systems, and that describe, but they're applied in the health and medicine, but they describe different approaches in the informatics. Then what is the search engine? There are a lot of search engines available in the internet, but still the quality of the search engines is not enough to satisfy the users. So a lot more search engines are developed, and because of the quality of the search engines, that is not the search of and our research to have a better quality search engine. So to fight with these problems, the problems came from the short and vague information that people enter inside of the users enter inside of the search engine, inside of the request for information, and the increasing volume of the data. And to fight with these problems, we can use the semantic technologies that make the link between the words, agent technologies, and personalization techniques for searching of information. For defining the information about COVID-19 represent several challenges. I'll talk about COVID-19 first, and then I'll move to the ontology and the system. The COVID-19 data is increasing constantly. Data is available in internet and also available articles in internet for COVID-19. So that the problem to have up-to-date information is also increasing about COVID-19. And the models represented about COVID-19 need to be up-to-date and modified reasonably. Then embedded knowledge about COVID-19 increase also, sorry. And the data relationship are defined from the various information that also make the problem that the information is increasing and the diseases are changing. And now COVID-19 impact all human domains, not only only the health of the people. It impacts after the pandemic. They measure that the level of pollution is less than now. It's because of the people was staying at home, so they don't use so much their cars. That impacts a lot and that helps to the environment. Actually, the impact of COVID-19 to the people then gave some positive impact to the environment. And a lot also, especially for the economics, it was very, the impact was very hard because the economics was, some domains, human domains were very impacted and they didn't work for a lot of time and they still cannot develop in their full capacity because of the pandemic of the COVID-19. And also it's COVID-19 interact and stop more or less our human communication. And it makes the communication in a different way, in a distance that was not, that change also the human interaction and the human communities, and it changed also the human economical development. But I'm going to talk about only for the COVID-19 as now as a problem that impact the health. So I'm going to propose a system that will help to people that want to search information in internet. And then, as I was doing an article for the knowledge graphs and ontologies, I make a summary about all knowledge graphs related with COVID. And the basic knowledge graphs that are used are COVID graph, KGTK COVID-19 knowledge graph, Blender Lab COVID knowledge graph, COVID-19 knowledge graph, and COVID COP. Another is a knowledge graph that proposes more general information about COVID. Here are the websites Spoke, UCSF, Edu. It this website contains information about the treatment, the disease, the gene, protein, structure, data, drugs, and other. As you can see, information. And CNET miner.com. It's I'm sorry about my English. Sometimes I'm making a mixture. Maybe then you some search engines available in internet. I'll mention the sketch engine, Sinequa, COVID-19 intelligence search, Microsoft Cort19 search, and Amazon's Cort19 search. That's industrial, available to everyone, search engines. Then a search engine that use retrieving documents containing nearest neighbor span as a result. That's a COVID paper browse, Corona search, and COVID Scholar. Search engines that gather data from different sources, COVIDX, FATCAT, DocSearch, COVID-19 Intelligent Insight, COVID Artificial Intelligence Powered Search, COVID-19 Navigator, and COVID Scholar. Leverage external knowledge graphs for entity linking. That's Vepper, which links to Chemprot, COVID-19 Navigator, and Evidence Miner, which links to UMLs, or AWS Cort19 search. My objective of the system I'm proposing is to work with the big data as the data increase in internet, and the system that will work with fuzzy and uncertain information that the user are going to insert into the system, into the query. And for that, I'm using personalization, semantic, ontologies, intelligent agents, and fuzzy, and I'm implementing fuzzy and probability theory, fuzzy logic and probability theory. So I'm investigating the problems with the reasoners and the modification of and creation of ontology. I was talking about knowledge graphs that are related with much more related with COVID-19 information. And the system I'm going to describe is created with a specific model of ontology. That's a research field that need to be modified and to be tested. Otherwise, the information for COVID-19 is much more appropriate and much more available for the knowledge graphs than the ontologies. there are ontologies for COVID-19, but not so specific. And for that, it is integrated also mobile agent for the extraction of the information from incomplete and contradictory information environment from the internet sources. And it is created a user profile that is related with the personalization. So I'm proposing a conceptual model for personalized semantic search system. A system that was partially developed in the level of prototype, and evaluation of the results, of the possible results that will be presented. So the search of the information in internet is performed. I'm sorry about this figure. It is, I'm going to explain more. It is done with a mobile agent. One mobile, maybe it's not appropriate to see. Then just briefly, I'm going to say that the mobile agent is going to search information into different websites that will specific websites, because as you can see, there are a lot of sources for COVID-19 in internet, but just some specific websites have the correct information for COVID-19, so that the user cannot estimate that, so that it is proposed a website from where to search the information with a mobile agent. The mobile agent is going to go from one site to the other site. That's why it is used a mobile agent, not a coordinated agent that will go from one side gathering information and then will go from the other side. That will take also much more time. So to model the semantic search system, it is to work with a big volume of data. It is adapted, the system is adapted to work with big data and to work with vague and uncertain information from the user. Here is the model of the system. It is designed with mobile agents. The interface agent receive the user query from the user. Then the manipulation agent modify the query concerning to the spell checking and the available ontology, domain ontology, and also the words. And then the information from that, then this information concerning to the symptoms that the user enter into the system, the information of the symptoms and then the diseases related to the symptoms is searched with the use of the mobile agent that go through different websites, that go through a website that extract the information for the diseases, for COVID diseases, and the description of the different symptoms of the COVID. And then for the agent that propose solution for these symptoms for COVID, so that the user then will receive the result as a solution for the COVID. Also, on the upside of the model, there are available external sources as different sensors and web services that with interaction of the user profile, and a user profile related with the user information and with the personalization of the system. For the creation of the system, so that to adapt with the technologies and with the requirements of the quality is used also, as you can see in the the agent for the personalization of the results, a hybrid reasoner. This hybrid reasoner is described later. I will describe now the user profile of each user using the system, that includes basic information and is defined as a model of ontology. A basic information like name, age, sex, profession, residence, then statistical data as previous search queries, history of data, visited search results, and annotated queries. Basic medical information for the user: weight, height, blood type, body mass index. And then the medical information, specific medical information for each user: pregnant, smoker, chronic disease, allergies, medical history. And the component of the ontology related with the condition of the user and the symptoms of the user, and then so that to return a diagnostic or return result to the user that will propose him a solution for his problems. For the COVID-19, for the solution, it will be just a diagnosis, not so much a solution. I mean, for the COVID-19, the specific information will be not to concerning to the symptoms. We can evaluate that these symptoms will go through to the diagnosis of COVID-19. So we can say that if you enter to the system that you have such kind of problems, we can evaluate your symptoms that maybe you can have this COVID problem. The hybrid ontology, the ontology is hybrid because it is related with fuzzy logic. It uses fuzzy logic, probability logic, it is case and rule-based also. For I'm just briefly explaining the fuzzy logic, but probably you're quite aware about that. It's about for in the fuzzy logic where I'm using the many valued logic function, the membership function that can be related with the probability theory and levels of here in the fuzzy logic we have the levels of truth, and that could be also interpreted as in the levels related with the probability something to happen with in the same diapason of 0, 1. The model of reasoner is defined here. The algorithm for big data reasoning from vague and uncertain requests defined firstly, the algorithm is also hybrid, so that it use several two algorithms. The first algorithm is adapted for big data using big data, so that it defines the distribution of the data, and then the data are separated into groups concerning to the symptoms of the disease, and then of the symptoms related with the specific user, and then it is applied an algorithm for reasoning for standard ontology and measurement of the semantic similarities. That's the big data, the algorithm applied, so that there are different peers concerning to each symptom of the COVID, and inside of each peer, actually, then the algorithm is applied for reasoning to each peer as the rules are applied. That's a rule-based algorithm. That's to apply that algorithm to the ontology. The ontology is adapted to be rule-based, so that to be able, so that to be adapted to work with big data. Then we are having definition of the number of the peers equal to the number of the key values. For each concept or for each symptom is needed to connect the concept with the peer, so that to have the same number of the key value of each case, as the ontology is case-based. I'm going to describe the case-based part of the ontology later on.
Mariya, you have about 10 more minutes to speak, and that
really?
would give us about 10 minutes for the questions and answers.
Okay. Okay, then I'm continuing. I'm going to show the prototype. For the software I'm using is jColibri for the prototype. It's case-based. It's a software for prototyping. and it is case-based. Also, I'm using Jade and Protege for the creation of the ontology. That's the architecture of the personalized search system. Concerning to also, it is yes, it is much more describe the model of the personalized search system. Here there are the different agents and the usage of the coordinator agent between the medical and drug diseases. So the between the medical information in internet and the disease information in internet, so that to propose an information in the end to the user. And the case-based ontology. Here is the case-based ontology. We are having the solution of the description of the case solution, and then the weight, the symptoms, the medical history, smoke, all the components of the ontology. And as a value, they have a fuzzy part of the ontology. Here is the fuzzy part of the ontology described, and the levels of the membership function. This is an additional, to create the fuzzy part of the ontology is used an additional plugin, fuzzy OO, and to create the distributed part, or the part that will help to work with big data, is use the these attributes has peer and has factor, so that to be related with the reasoning algorithm. And that's the experimental, the results of the system evaluated from an expert, and the results from the return from the system. So that this gave, that's the interface of the system. This is a very general query. It's for health disease, but it could be adapted for precise for COVID-19 information. And this is a brief description of the interface of the jColibri and their usage for case-based reasoning, for case-based applications, so that adapt each time with a different, and that they are updated with the different cases, so that the information is more correct. Thank you very much.
That was good. Thank you so much. I would request that we open now this question answer period now. So Mariya, very excellent talk, and Ram, you want to say something? I have a couple of questions for her, and so does Gary and others.
So I'll let others ask the question. Nice talk. And also it'd be, I guess these things will be asked during the question answer session in terms of how exactly the ontology was used to guide the search. Okay. So maybe, it's something to keep in mind. You showed some ontologies in Protege, but it'll be nice at some point, maybe it's there in your slide. I know we had some time problem in terms of how much we can compress in 45 minutes, but it kind of will be useful to know like some ontologies that you can show how they were actually used in search, in helping the search better. Like you said from
Yes.
Google, you gave an example of Google search, for example. How is this like in Google? What do they do? And versus the kind of search that you did, how is that? How is this better than that?
Because it is case-based. It means that all the cases entered into the system are saved, and then this information is used from the system to with the other cases.
Okay.
It means that make it more it's much more appropriate, more dynamic, and adaptable to the cases and to the new cases also.
Okay, thank you.
Bobin has the same question. I have a question on case-based reasoning as well. So please, first say, Gary, you go ahead.
Okay, thank you. So I had two questions about the ontologies in a sense. One was you mentioned the ontology was rule-based or related to rules. That to me sounded like that's the way some of the knowledge was represented, but I didn't quite know what that meant. And then the related question, similar question was, your cases seem to be to make up a knowledge base as opposed to an ontology in my thinking. So you have these large structures of cases, which are made out of various structures and relationships. And if we understood the structure and the relationships, we'd understand a little bit more of the case base in terms of an ontology. So anything you can say about that would be interesting.
Yes, actually the algorithm for reasoning is defined with parts. The first part is with working with big data, and then the similarity function, so that with the big data, I'm separating the data into different concerning to the symptoms, so or concerning to the cases, and then I'm after that I'm using the appropriate algorithm for reasoning with similarity function that was used for another system for diabetes diagnosis, and I'm adapting to work with also with the big data, as I'm using this case-based reasoning.
So you would say in part that your cases are divided by the nature of the symptoms or the treatment, or
for the symptoms.
The symptom, it's based on the symptoms. Yes. Okay. And they are longitudinal in nature. That is to say, the case comes in and there's one diagnosis based on some symptoms, and then there's a treatment, and then there's some evaluation.
Actually, the symptoms are also related with a part of the body. You can have a headache, then you can have a symptom, another symptom related with your stomach, or with another part of the body. And the interesting is that, for example, COVID is something that is very, it's not related with one part of the body. The symptoms are related with different parts of the body. So that to separate the cases related to that, I'm using this, and to separate the retrieval of the cases, I'm using this algorithm that was adapted in another case, but it is that was adapted to work with VAC data And then I'm adapting it to work with medical data. So and I'm applying it to this
Yes.
hybrid reasoner that will give more appropriate result to the user.
Mariya,
Qualified result.
just to take it further, Mariya, Bob in Tea Garden and I have similar questions. The case-based reasoning systems generally guide you for a given case, for a given user with symptoms. It will guide you to a repository where such similar symptoms cases are pre-stored in the repository. So you will try to find a closest match. What are the criteria for those matches is our question. If it does not match, does it search nearest neighbors, or what algorithms you use to find similar symptoms or similar cases?
Yes, it is described in the articles. It is used a similar neighbors algorithm, but the algorithm is adapted and it was applied in another system for diseases yes, just I probably it is adapted for disease for diseases of diabetes.
Mm-hmm. Now, when you have uncertainties, you have multiple choices. And how do you use which choice you want to use for a particular case? How you use the probability theory? What decision-making rules do you use?
It depends of the rules. That are entered into the system, and the rules also will depend of the query defined from the user and the information defined from the user. It means that the information from the personalization profile and the information from the user defined when he entered the query, he or she.
Thank you. Other questions? What do you need to do to refine your work forward? What are the challenges you are facing in applying especially the fuzzy logic and uncertainty reasoning? That is, of course, really a futuristic view and good. I'm glad. I like fuzziness entered in real life. It's all fuzzy. It's never 0 or 1. So please, your thoughts as to where will you take this research further?
Actually, the fuzzy logic and the probability is used with the relation of also with the reasoning. It will affect the reasoning, and it affects the reasoning. That's why it is implemented. Actually fuzzy logic, yes, the constraint of the fuzzy logic is that I'm just moving to very to more wide data. I'm characterized, for example, the body mass index to good or bad, or to 3 different stages, not to particular data. But that's, for me, that's also an advantage, because if I'm using the fuzzy data for the, it could be a solution for the big data, because there is no need to store a lot of information. And I mean, I'm having I'm receiving a specific information, but then that information could be processed with fuzzy information, and to become a specific data to good or bad data. I mean, for example, the body mass index, you have 3 levels. Either you're having a good body mass index, that is healthy body mass index, either you're having not healthy body mass index. And it doesn't so much precise the specific information from the user. And that's the idea why I'm using the fuzzy data and probability theory here. It's because the user normally is entering into the query brief information, 2 or 3 words. And from these 3 words, I need to return to the user reasonable query results. And these query results can, and as much as I'm having much more I can say to this user about his condition, I can return much more precise results.
So what I understand is that something like Bayes' rules, you are applying Bayes' theorem and defining pre-considered levels, like 3 for the case of BMI. But you could as well have multiple levels in more advanced work later, where you decide at the processing time how many levels of uncertainties and what decision rules will you apply, similar to Bayes' theorem.
Yes.
Thank you. Any other questions from our participants?
This is Gary again. You had a slide where you talked about leveraging an external knowledge graph for entity linking. And I was just wondering if you could say a few words about that knowledge graph. I think you called it Vapor with links to Chemprot. Is that the major knowledge graph that you're leveraging?
Yes, I'm. The knowledge graphs are available in the internet, and yes, but they. I just make a brief introduction to the knowledge graphs available for COVID-19, and that a lot of information, a lot of knowledge graphs are available in internet. And
yes, so is one way you're using that, you talked about entity linking, is that you're taking the words in the query and relating them to things that are in this knowledge graph and getting a larger context for some of the concepts being used in the search items? Is that the way you're using it?
No, actually the knowledge graph, I'm not using this is, I'm planning to use the knowledge graphs. It could be used as an information. Knowledge graphs from internet, from that system, could be used as an information from internet, so that the system the agent, mobile agent, can take information from the knowledge graphs available from internet. And with this, with the links into the knowledge graphs can extract information related with the drug, about the drugs and the symptoms and the drugs about the COVID, for example.
Okay. Thank you.
Because this inside of the system, it is adapted to work with this model, and it could be this model for case-based reasoning, and in the future it could be adapted these cases to be not in part of this information to be stored into knowledge graph and more in a more not to be so precisely structured here as here in ontology.
Thank you.
If there are no more questions, I suppose it is about time. Ram, any concluding remarks?
Nothing, just thank Mariya and
Excellent talk, Mariya, and continue, especially your fuzzy and uncertain ontologies. Thank you.
Thank you.
Thank you very much.
until next